about today's topic is about dynamic order status update. Introduction to order management systems. Order management systems track customer purchases from placement to delivery, ensuring accurate and timely fulfillment. These systems integrate with inventory payment and logistics services to provide a seamless user experience. A core feature is real-time status tracking, which informs users about their order's current state in the fulfillment pipeline. Dynamic updates enhance transparency and reduce customer support inquiries by providing timely information. Dynamic updates enhance transparency. In web systems engineering, such functionality requires useful design of data flow, state transitions, and user modifications. Next, key components of dynamic status updates. Backend services maintain the authoritative state of each order using persistent storage like relational or NoSQL databases. Front-end interfaces display status changes through dashboards, emails, or mobile push notifications. Event-driven architecture enables immediate propagation of status changes across system components. APIs act as intermediaries between front-end clients and back-end services, often using REST or GraphQL protocols. Message queues like RabbitMQ or Kafka decouple status producers from consumers, improving system scalability. State machine design for order lifecycle. Order process progress through predefined states such as pending, confirmed, shipped, and delivered. Each state transition must be validated to prevent invalid jumps like moving from pending direct to delivered. Guard conditions ensure that transitions occur only when prerequisites are met, such as payment confirmation. State machines can be implemented using finite automated principles, often modeled with tools like UML state diagrams. This structured approach simplifies debugging, testing, and auditing of order flows in production systems. Real-time communicable mechanisms. WebSockets enable full duplex communication between client and server, allowing instant delivery of status updates. Server sent events SSE provide a lightweight alternative for one-way streaming from server to browser. Long polling simulates real-time updates by keeping HTTP requests. HTTP means hypertext markup language. Requests HTML open until new data is available. Each mechanism involves trade-offs in complexity, browser support, and scalability under high load. Choosing the right method depends on use case requirements like update frequency and client capabilities. Then, database considerations for status tracking. Order status is typically stored in a dedicated table with fields for order ID, current status, timestamp, and metadata. Indexing on order ID and status fields improves query performance for user-facing status checks. Audit logs track every state change, supporting traceability and compliance with business policies. Optimistic or pessimistic logging prevents race conditions when multiple services update the same order. Time series databases may be used for high volume logging of status events in large scale e commerce platforms. Then, event-driven architecture and microservices. A microservices-based systems order status updates and published as events to a central message broker. Services like payment, shipping, and notification subscribe to relevant events and react accordingly. This decoupling allows independent scaling and fault isolation across different system components. Event sourcing can be used to reconstruct the full full history of an order by replaying recorded events. Tools like Apache Kafka or AWS Event Bridge facilitate reliable event distribution and processing. Then, main front-end implementation strategies. Single-page applications (SPS) use frameworks like React or Wave to dynamically refresh status without page reloads. Status indicators are often visualized using progress bars, color-coded badges, or timeline components. Client-side catching, catching reduces redundant API calls while ensuring data freshness through periodic polling or push updates. Error handling must account for network failures, displaying fallback messages or retry options to users. Accessibility considerations ensure status updates are perceivable by screen readers and keyboard navigation. Security and data integrity concerns. Order status endpoints must be protected with authentication and authorization to prevent unauthorized access. Role-based access control ensures only authorized personnel or systems can modify other states. Data validation prevents injection attacks and ensures only valid status transitions are accepted. HTTPS encryption protects status data in transmit from eavesdropping or tampering. Digital signatures or checksums can verify the integrity of messages in distributed environment. Scalability and performance optimization. Catching layers like restore frequently accessed order statuses to reduce database load. Database read replicas handle high volumes of status lookup requests from users. Asynchronous processing offlines non-critical tasks such as sending confirmation emails to background workers. Rate limiting prevents abuse of status update APIs during peak traffic periods. Horizontal scaling of stateless services ensure the system can handle growing user demand. Error handling and recovery mechanisms in, idempotent operations ensure that duplicate status update requests do not cause unintended side effects. Deleter quicks capture failed messages for later inspection and reprocessing after issue resolution. Retrieve policies with exponential backup help recover from transient failures in dependent services. Circuit breakers prevent cascading failures by temporarily halting calls to unresponsive components. Comprehensive logging and monitoring enable rapid detection and diagnosis of status update anomalies. User experience and notification design. Notifications should be timely, relevant, and non-intrusive, respecting user preferences and quiet hours. Multi-channel delivery, email, SMS in-app alerts ensures users receive updates through their preferred medium. Personalized messages include other details, estimated delivery times, and actionable next steps. Users should be able to opt in or out of specific notifications to verify. to types via account settings. Clear language and visual clues reduce confusion and build trust in systems reliability.